Congratulations. Really happy for you. Okay, everyone should have one of these little orangey or white sheets in front of you. Yes, we're on the graphing side. So you should have done this before. Let's see if you can do it without calculators, the first 4. So it tells you x equals -3. So you're going to take that -3 and you're going to pop it into this x right here.
So you do 3 times x times -3.
6, right? See how there's a 6?
That's what I meant.
Exactly. Yep. So you're going to do 6, and then instead of x, you're going to write -3, and then plus 2. So can you do 6 times -3 without a calculator? -18. Hallelujah. Okay. And what's -18 plus 2? -16. Beautiful. All right. So the first one is -16. So write that and circle it. You guys have done this before. This is called evaluating. This is when you plug x's in for certain values. Pretty easy, yeah? All right, I'll do one more, and then you finish the rest. This one, x plus 5 is x equals 3.
8.
So just plug 3 in for there. Yep, 3 plus 5 is 8. So that one was easy. All right, can you do the next two?
13.
Don't say it out loud yet. All right, do it real quick in your head. I'll give you like 30 seconds. Is that enough time? No. Griffin, I'm going to ask you for the third answer. Because I feel like it. And we'll have Brittany give us the fourth answer. Deal? Cool. All right, 10 seconds. 8.
Just the first 4?
It's just the first 4. 5, 4, 3, 2, 1. Okay, your time's up. Griffin, are you ready? Okay, tell us about this third one. Did you plug in 3? So 3 times 3 plus 4. What'd you get? So you did 9 plus 4 is, did you all get 13 as well? Amazing. Good job. It's 13. Perfect. All right, and then Brittany, tell us about the last one. Fabulous. Okay, what's -3 times -2? Positive or negative? Good. All right, the last one's +6. Do you guys get all those correct? Okay, we're going to be using this today, obviously. This is just the easy version of it. Okay, the last thing you have to do is you have to do this quick graphing review. So the first 4 are lines and the bottom 4 are parabolas. Did you notice that? Okay, I'll review one of each, then you do the rest. First one is -2x plus 3. So y'all keep messing this up. Where do you start? Do you start at the 2 or the 3? The 3, right? It's because it's up. It's on the end. So go up 3 to start and put a dot there. I know these graphs are so small. Can you kind of see them? I had to make them small to fit them all on here. All right, and then your slope is the number in front. So it's -2. So how do you slope -2? What does that mean? Down 2 over 1. Okay, this is the moment of truth. To the left or to the right?
To the right, up, down, left.
That was all the answers.
Like,
okay,
right.
When you're drafting lines, you go to the right every single time. You never, ever, ever go left, unless you're doing like some weird opposite thing. But in general, if the slope is -2, you go down 2, and you always go to the right. Down 2 over 1, down 2 over 1. And what that does is that creates a negative slope, which is exactly what we wanted. If it's a piecewise function, you might use this other side, but it's still a negative line. So that's graphing lines. Cool. Okay, the last one, the last row is going to be this x squared. So this is where you have the parabolas. So a -x squared, there's nothing else. So you start at 0, 0. And then it's a negative slope. So how do you do -1 on this one? You go down 1. Do you go right or left? Both. You go both because it's a parabola, right? So you go down 1, right 1, and down 1, left 1. Except for this isn't the one that keeps going. It like gets skinnier, right? So go ahead and draw your parabola. It should be facing down, and it looks something like that, right at 0, 0. Remember this? So today I'm going to make you do piecewise functions now with parabolas. Oh.
Hello?
Beautiful. Thank you so much. Yeah, I think someone else is trying to get on mine. There we go.
Why?
Sometimes you can connect to other people's, other teachers. Sometimes they like accidentally choose the wrong one. Yeah, that's really rude. All right, you guys have 9 more graphs. 6 more. I can't count. You have 6 more graphs to do. Oh my gosh. can see them doing stuff. We good? Yeah, I don't know. I'm just trying to figure it out. All right, take a second and finish these last 3 graphs. Does anyone want to do them on the board? I'll randomly draw you all when you're done. All of them. You have to do these 3 and these 3.
That's not 3.
I mean, so 6 total. Okay, you get half a song. Is that enough time?
No.
Well, too bad.
How about a bowl?
This is Let It Snow. Did anyone say that? No? Yes? All right. 1 more minute. Finish all these graphs. Make sure you're good.
But the fire is so delightful. Since we no place to go, let it snow, let it snow, let it snow. Oh, it doesn't show signs of stopping. And I brought some corn for popping. Lights are turned way down low. Let it snow, let it snow, let it snow. When we finally kiss goodnight, how I hate going out in the storm. But if you really hold me tight, all the way home I'll be warm. Oh, the fire is slowly dying, and my dear
James,
was still
I'm going to have you come do
goodbye.
one.
But as long as you love me so, let it snow, let it snow, let it snow. Oh, yeah. When we finally kiss goodnight, how I hate going out in the storm. But if you really hold me tight, all the way home I'll be warm. Oh, the fire is slowly dying, and my dear, we're still goodbye.
All right, time's up. That was more than half the song. Wow, generous. All right, James is going to do our first one, and let's see if he gets it right. Please ignore the camera. Pretend it's not there.
Okay, look. So, slope is up is 1 over 1 because that's what x equals. So we start on.
Yeah. Thank you. Versus on my video.
Up 1 over 1.
Yep.
And up 1 over 1.
Good.
And up 1 over 1. And et cetera, et cetera.
Okay.
And draw a line.
Ah.
Arrows.
Okay. What about the other side?
Arrows.
Ah, yes. Could you extend the line? Like, could I keep going with this line and go all the way down this way?
Yeah, that's why there's arrows.
All right. Well, I just want to make sure. What if it was piecewise? You need this side. Amazing. Thank you. All right. Did y'all get that right?
Yeah.
Goodness. All right. This one, I'm going to do the last ones, and then Griffin, you can do the last one if you'd like. So up 2, this one's up 1 over 2. So this one's a little bit flatter, and it crosses at 2. Good? This last one is negative 2x. It starts at 0. You go down to right 1. So this one's looking like this. Cool. 2x squared starts at 0, up 2 over 1. This is just like a skinny parabola that hits at 0. And it's facing up. Yes? This one goes down 1, and it's negative. So it looks like this. And it crosses at negative 1. And the last one. Griffin, that's you.
Oh, that's me.
Yeah. Chip chop. All right, explain it. How do we do it?
Okay. You go up 2,
Beautiful.
and then you go up 1 over 3.
Exactly. Good.
And you do it on the other side too.
Perfect.
And then you can draw your O's.
It's hard on the TV, I know, but that looks fine. Just keep going. We get the gist of it.
Yay.
And then you have some arrows at the end.
Yes.
Beautiful. Amazing. Even faster.
Yeah.
Not that it's a
I'm better than
competition.
James.
All right, did everyone get those correct? I want to make sure you can do these pieces so that you can do the harder pieces. Yes? All right, beautiful. Okay, take this yellow paper now and flip it on the back. All right, this is going to kind of set up what we're going to do today. So, I'm going to use my dad as an example because he's a businessman, and so I always use him for business examples.
What's to do in business?
He's a venture capitalist in Salt Lake.
Venture.
Long story. I'll explain it to you later.
There's a game. Like, it's called that.
There's a game called Venture Capitalist.
Yes. I have like $1 million on it.
Congratulations.
Actually, I have like
There's also adventure communist.
A little different. All right. So what happens is when my dad was in college, yes, he started this company called Mobile Lube. So like an oil change company, yes. And what they would do is you would call them and then they would come to you. So instead of like Jiffy Lube, yeah, where you have to drive there and get your oil changed, you'd say, hey, I need my oil changed. They'd come to you and they'd fix your car and change your oil, whatever. Yeah? So this is when he was in college. So he started this company. The thing is it was expensive. So he started with, if you go over -6, so we start at -6, he started with 4,000. So these numbers are going to be in thousands. So started with $4,000. Put a dot right there on your graph. That's how much money he had initially just in his savings. And so to start this company, what do you have to buy if you're going to be a mobile lube company? So I'm just doing times, like I'm just going to say that -6 equals, 1980. And then we'll move on from there. Exactly, but we can set whatever limit we want for the x-axis. So that's what I'm going to do. Okay, so you're running this company. You need to get to places. What do you have to buy?
Cars.
You have to buy a car, right? And then you're changing people oil. You have to buy gas. You have to buy oil. What else? Maybe employees, right? Do you see how you're spending a lot of money doing this? Yeah, tires. So what's happening is he's going over one, down one. He's losing like $1,000 pretty rapidly, unfortunately. Yes. So he goes all the way. Actually, let's stop at -3 because this was a critical year. All right, so we have this line, and he's losing money because he's buying a lot of things. Yes. So then, finally, after he's bought all of this stuff, he has one more big purchase to make, and he hires a couple people to help him. So he spends his last $1,000 all in one day, and so he's broke. He's at $0. He spent all of his savings. So put a dot right there at -3. Then, after he's bought all this equipment, now he gets to run his business. So now, this whole time, he's been building up clients, he's been practicing. Finally, he has like these people who are hiring him to come do this oil change. So eventually, he starts making money, yes? And at first, it starts off kind of slow, but then eventually, this is going to be a bad picture, then eventually, it starts to grow. And that's kind of what a lot of companies do, is you spend the money and you put in an investment, and then all of a sudden, you've already spent all the money. So then all the money that you make is revenue. Does that kind of make sense for what the situation is? Yeah? Spend money to get money, kind of, right? So this is a piecewise function because there's two pieces. There's one he was spending money and one he was making money, yes? So if you're going to write a piecewise function, you can start with y equals, and then you got to draw the big bracket thing. Yes, we remember this from last time. Chapin, if you weren't here, this is how we write piecewise functions. You write it as a normal function, but it's in two parts. So we start with this first part right here. Can you guys tell me the equation of this line? Is it going to have an x or an x squared? Just an x. Okay, Porter, how would I find the equation of this line?
So it would be negative since it would be like reflected be going up.
Amazing. So you can tell it's going down 1 over 1, right? So this is going to have an equation of a -1x as the slope. Amazing. But where does it cross the y-axis? If I were to extend this,
-2.
see, it would hit at -2, right? So what do I do with that?
Then you x
Plus
than
Ooh, not yet. This is still part of the equation. So you just do a -2 on the equation,
Oh,
right? Because that's where you start. Perfect. Good job. All right. And tell me, this happens only if x is what?
So it's in between. So it's greater or less than or equal to -3 and less than or greater than or equal to -6.
Perfect. Yep. So you can be really precise. If we pretended that this was just a line, then we can just say that it would be less than -3. Is that okay? Even though it's not, but yes. On your homework and on your test, it's not going to have like points like that. So -3 is our breaking point. As you guys noticed, that's where it was splitting. So this first function we use for if x is less than negative. Are you kidding me? Why is this so difficult today? What? Oh, there it is. We're good. All right, x is less than -3. So we use this line function anytime we're left of -3. We're less than -3, we use this line. What happens if we are greater than -3? What's our equation for that? It's not exponential, it's actually quadratic. So if it's quadratic, you have an x squared. Yes? Can you guys find the slope for this one? It's going to be x squared. If I start here, I'm going up 1 over 1, 2, 3. Do you see that? Up 1 over 3. So my slope for this one is 1/3. Cool. And I didn't move up or down, but I did move to the left, didn't I? How many spaces to the left did we move? 3, right? And so if you're moving to the left, it's actually positive. So plus 3. So that is your equation for this second graph. We're just using the half from when x is greater than -3. This one was a filled-in circle down here, so I'm going to put my line underneath this one right here. So it's less than or equal to. So this one's kind of hard. These equations are hard, and I won't give you too hard of ones on the test, but I just wanted you to see that that's how you can have a piecewise with a squared graph, kind of. All right, so there's your piecewise. The last 3 questions are evaluating questions. So how much money did my dad have at x equals -3? So come over here to -3 right here, and sorry, I've drawn all over this. This one was an open circle, and this one was a closed circle. So at -3, did he have $0 or did he have $1,000? Why do you say 0? Because it's filled in, right? Yeah, exactly. All right, so how much money did my dad have at -3? 0. We're going to use wherever the closed line is for that one. So you can just put in parentheses because that's where the closed circle is. All right, how much money did my dad have at x equals 0? X equals 0 is right here. How much money did he have? Can you tell? Yeah, right here. 1. And because this is in thousands, he had $1,000. So after 3 years, he had $1,000 again. And finally, how much money did my dad have at x equals 2? X equals 2. Can you tell from the graph? It is kind of iffy, right? It's not perfect. So maybe we could use our handy-dandy equation. So x equals 2, that's when x is greater than -3. So I'm going to use this equation right here. So plug it in. 1/3, and instead of x, we're plugging in 2 plus 3 squared. Let's see what we get. So do the 2 plus 3 first, which is 5. What is 5 squared? 5 times 5, 25. Good. And then finally, can you take 1/3 of that? Oh no, you don't have calculators. What's 1/3 of 25? You want to cheat and use your phone. So that's the same thing as just doing 25 divided by 3. That will give you 1/3 of that. Yes? I need someone to type it in for us. I need to know. 8.33333. Awesome. Okay. So 8.3 is like 8. And remember, this is in thousands. So by x equals 2, had about $8,300. Sort of. Okay, what questions do you have about this? Yeah. Good. So you can always just look at the graph to figure it out, but if it's not perfect or maybe you don't have a graph, you can use the equations and just take the x and plug it in. That's why we practiced it on that little yellow sheet, you know? Cool? All right, there's your introduction. So take this paper, you can just leave it for help, and now I'm just going to give you your homework. And I'm going to do the homework problems, a few of them with you, to get you started. Is that cool? No. 15. You want to do your homework problems all by yourself? You want to do all of them with me?
Yes.
Ah, no.
What's recording?
Yeah, I'm just going to leave it recording until I finish this. So here is your white homework. You do have to do front and back, but like I said, I'm going to do half of it or so with you right now. 3, 4, 5, 6. Let's just leave them back there. And Lucy, you got one? Hi, students on the video. So this is what we're doing. This white paper right now. I think it should work. Do I have it up here? Cool. All right, guys, we're on the side that says part 1, evaluating piecewise functions. So go to part 1, and now we got to practice actually evaluating them. Just like we did before, but now with a piecewise function instead of a regular linear function. Okay, I think we should start with number 1. Does that sound good to y'all? Number 1 is I want to know what the function is at 15. So that means x equals 15. So come over here to our beautiful, cute little piecewise function. And we got to figure out if we should use the first one, the second one, or the third one. Which equation do you guys want to plug in 15 to? First, second, or third?
The first one.
The first one. Okay, the first one is only when x is less than -2. Is 15 less than -2? Nope, can't use the first. The second one is if it's in between -2 and 5. Is 15 in between -2 and 5? No. And then the last one is if x is greater than 5. Is 15 greater than 5?
No.
It is, of course it is. So, this is the equation you're going to use. It's just 4 times x. So you just write the 4, and then instead of x, we're plugging in 15. So, we can do that in their head. What's 4 times 15? 60. Good. All right, so number 1, the answer is 60. How's that? That makes sense, right? Okay, let's do another one. Let's do number 2. Number 2 is f of -2. So, which one of these equations now, let me clear this off, is -2?
Second one, right?
I don't know. It's the first or the second? So the first one says if x is less than -2. Does it say it can equal -2? Nope, so it can't be the first. But the second says, see how it has this equal sign right there on it? It can equal -2, so we are definitely using the second. You're right. So do it. X plus 2 is your equation. X plus 2, and you're plugging in -2 for x. So -2 plus 2. What's -2 plus 2? 0. Yep, good. So this one's 0. Beautiful. Yes? Is that easy enough? Can you finish this for homework? Is that enough example? I can do another one if you want me to. I think you guys are good. Finish 3 and 4 by yourselves for homework.
That's all homework.
That's all I'm homework.
No, this whole paper's your homework.
Oh, yeah.
But anything I don't do with you will be homework.
That's not fair.
I think that you can finish those ones by yourself. You can do them right now real quick.
Usually auto homework.
Yeah. Okay, take a second and do those 2 right now by yourselves, and then we'll check and see if you're doing them right. Yes? So do 0 and -8. Did you guys get 2 for the second one? Easy? Or for the third one? What about this last one? Number 4. This is for f is -8. Which equation is that? So -8 is not greater than 5, and it's not in between -2 and 5. -8 is less than -2, right? But there's no x to plug it into. Right? So what's the answer? Just 3? Yeah. You just literally write 3. It's going to be 3 the whole time. So the answer to number 4 is 3. Number 1 was 60, number 2 was 0, number 3 is 2, and number 4, that looks like an 8. It's a 3. It was 3. Good? Questions? Deal? Okay. The last thing you have to do on evaluating is you have to be able to evaluate from graphs. So let me scoot this up so you can see it a little bit better. All right. So I've got just 4 questions for you, and you're going to use the graph. So we're going to start with A. Where's the graph when x is -3? So go to the x-axis, and when x is -3 is going to be right here. So here's -3, and then you just go up to the graph. Where is the graph at -3? What value is it? 1, right? So then you just write 1. That one's a pretty easy one. Pretty obvious. A little bit trickier is B. Where is the graph when x is -1?
1.
Ooh, okay, so you go to the x-axis,
No,
and you go to
that's
-1. There's 2 options. There's this one up here, or there's this one down here. Why do you go to the -2? It's close. You see how this one's like filled in? So it is this one, it's this one, which is negative 2. This one's open, so that one doesn't count. So negative 2 is that answer. Right? All right, when x is 0, yep, go to 0, and then you go straight down, and the graph is at negative 3. And then last one, when x equals 2, you go over to 2. Can you tell? I think it's 1. I think it's right at 1. Doesn't it look like it's right at 1. All right, so then positive 1. Easier, right? Graphs are easier than equations. But you just plug in stuff in, evaluating. Sort of. Okay. You guys are going to finish the rest of this for homework, but let me hurry and teach the other side for the video. So, take white paper, flip it on the back. And now you have to actually graph. So, I'm going to do one of these problems as a review, and then the second one we're going to do, which is new. Okay, let's zoom in all the way to this one right here. Okay, where do we start? You guys are going to have one of these on your test, so you got to know how to break into this piecewise.
I just divide for
Yeah, like done the division for piecewise.
Yeah.
Where is it split in half? Negative 1. Awesome. So you look at here, and you see where our piecewise is split at negative 1, so you draw your dotted line, or a solid line, whatever you're feeling, at negative 1. This is where it's getting split. Which equation is going to be on the left side? Usually the top one. No, this one, right? So negative 2x minus 1 is on this side, and then x plus 3 is going to be on this side. So hopefully you're using a pencil, remember, not a pen, so we can erase if necessary. Let's graph this. Uh-oh. Okay, we're starting with this one. This one has a cute little y-intercept of negative 1. Yep. So go to the y-axis, not your line, the y-axis, and you go to negative 1 on the y-axis. Then your slope is negative 2. So you're going to go down 2 to the right or to the left? Yes, to the right. So even though this is the equation on the left, still, you always go to the right. Down 2 over 1. All right, so here's your line, and you can go in reverse if you want, up 2, left 1, up 2, left 1. All right, so go ahead and draw your line. And then what part do I need to erase? The one on the right? Yeah. So this one only exists when x is less than 1, so that's to the left of the line. So I need to erase everything that's on the right side of the line. Right there. Cool. All right, beautiful. Now let's do the other side. The other side is x plus 3. X plus 3 starts at 3, up here. And then the slope is just 1. Up 1 over 1, up 1 over 1. So this one is just a straight, easy, nice line, and you go all the way until you hit the line, and then you stop. This one is a closed circle because it has that line underneath it, and then this one should be the open circle because it doesn't have the line underneath it. Add the little arrows. There it is. That's called a piecewise function. We did this last time, and this was your homework. Do you want to ask any questions about this? I know I did that one kind of fast, but it's because we already learned it. Good. Nothing's confusing, promise? Yeah, we can.
I was they're gonna ask questions.
They're like, hey, yeah. Hopefully not, because then I won't be able to answer their questions. You okay with this? Can I move it up a notch? All right, this is the basic. These are the easy ones because they're both lines. So the ones that you have for homework tonight, one of them is going to be a line and the other one's going to be a parabola. So, let's do it. Lucky for us, you can tell that this one splits at 0. Yes? So, draw your line at 0. This is where it's going to be split in half, so we just have one graph on the left side, one graph on the right side. Cool. Alright, we're going to start up here, where x is less than 0, which is on the left side, and we're going to graph the graph negative x. What's the y-intercept? Where does it start? Do we move it up or down? Nope, just 0. Start at 0 because there's nothing left. And then the slope is negative 1. That's your slope. So from 0, you go down 1, right 1. Down 1, right 1. Down 1, right 1. This is your line. So draw your line the whole way.
Are you drawing the wrong face?
Yeah, right.
Oh,
Right, it'll go both ways.
I know it'll go both ways.
So I draw my whole line, and then which one do you not need? I drew the extra one, right? So you're just using the left side, so you don't need this side, so erase this. So we're just doing the left side, because just when x is less than 0 do we have this line. Beautiful. All right, and then on the right side, we have the graph of x squared, which is pretty easy. No moving up, no moving down, no moving side to side. We just start at 0 as well. So start at 0. And then our slope of this graph is just a 1. So up 1 over 1. And normally we'd go to both of them. Normally we'd go to both sides, but you don't have to. We're just going to stay on the right side for this one. So just draw your parabola kind of like one-sided on this side, sort of. Does that make sense? Beautiful. There it is. So it's a piecewise function, just like normal, but one of them's straight and the other one's curved, right? Kind of like the equation that I showed you for my dad's company. Just there's no spaces, more continuous. Do you think you can do this by yourselves on your homework tonight? And or on a test? Sort of. It's the same rules. Okay, good. You just have to know how to graph x squared instead of x. So be really careful trying to figure out which one is which. Yeah? Okay, I'll do a few more with you, but that's it. This is your homework. So get together, work on this whole side and the other whole side. And then that's it. We'll do a partner quiz at like 8:45 maybe, if you have time before we leave. The end. Let's see if it was recording. Yeah. Oh, yes.